All right, so in this exercise, we're actually going to move this cube, but with code this time, which can be super useful in your games. We can't always be moving things with the handles while the game is running, right? So we're going to need things to move on the run. So what I want to do here is click on the cube that we used from before. Let's click on Add Component here and choose New Script. I'm going to title this script Move, right? That's what makes sense. And then the move script, move.js, is going to be added right down here to my project window. I double click it and it pops open in MonoDevelop. Perfect. Now, since I want this thing to move over time, I'm going to put it in the update function, which fires every frame. And I'm going to start off by writing the word translate. Now, translate in terms of 3D space actually means to move something, right? Like move its position, change its position, translate from one XYZ location to another. It has nothing to do with language or a different programming language, whatever. It's just translate, it's movement, right? But Unity has this built in, so it can move game objects, but it doesn't work just like this. What we're going to need to do is precede translate with transform. Now, where am I getting transform from? Well, transform is a keyword here that's necessary because the translate method, right, the function translate, belongs right in here, if I click on my cube, to the transform component, right? So it's one of the things that transform can do. If you've got a game object and the game object has the transform component on it, then we're able to translate it. Now, you may have seen in other tutorials or things like that, other documentation, something like cube.transform or even cat.transform or something like that, some reference to another game object and then a transform. We will use those eventually, but the reason we don't need them today is because this script, move.js, is attached to the thing that we're trying to move. So we can just go ahead and say transform. It's self-referencing. It's saying I'm referencing my own transform component. Now, the other thing that translate needs is an argument. It can take two arguments. We're just going to talk about one for now. And that argument is of type vector3. Vector3, of course, being an x, y, and z value. You can't just say, I'm going to move 6. You got to say, well, I'm going to move 6 in the y direction, 0 in the z, 0 in the x, something like that. Now, the way that I like to do these, let's say that I want to move this up. I'm just going to say 0, 1, 0 with commas in between. And I like to keep it at 1, even if that's not the speed I want, because you're going to see in a second, we're going to use a speed variable to control how fast it's moving. So I'm going to save, come back over here, hit play, and I should see my cube rise incredibly fast. And the reason it's so fast is because right now we're moving that 1 meter in the y direction every single frame, rather than, say, every single second. So the first thing we need to do to fix that right away is multiply this vector by time dot delta time. Now, delta time is the time that the particular frame took to render. So you're actually getting like, okay, how long did this frame to process compared to other frames? We'll talk more about how this works in a separate exercise, but for now, just consider this multiplying time dot delta time to be the way to convert from frames, let's say meters per frames to meters per second. The second thing we're going to do is multiply by speed, speed being a variable that we can control. We'll go more into depth in variables in another session too, but I do want you to go ahead and declare this variable up at the top here by saying var speed float, and we'll just end it there. Cool. And now let's see what happens. I'm going to go ahead and save this and come back over here. I've got to click on my cube, and I don't know, rotate myself around a little bit. There we go, cool. I've got to click on my cube here and take a look at my script, and I can now see that I have a speed variable, basically being kind of a value that I can change to be whatever I want. I'll change that to 5, and I'll click play once again. And this time I should see a much more controlled sort of move. Okay, it's still pretty fast, but the difference here is that this time I have a speed that I can mess with. So let me change this to 0.5 while the game's still playing. And then I'm going to double click my cube, and I can see that it's moving much slower now, right? And as I move this to, if I make this 0.1, it's even slower, right? 5 times slower than it was before. If I change this again back to 1, it's moving pretty fast. If I change it to 5, then it's gone again. Okay, cool. So I have movement under control. If I need to move an object, I can move it in any axis like this, based on a speed, based on seconds. That's great. So now what happens when I want to rotate it? Well, let me comment out this line real quick, and I'm going to do a transform.rotate. Same deal as before. Transform.translate and transform.rotate are both methods of the transform component. They both fit in this kind of space. So for rotate right now, let's throw a vector 3 into here. And I'm going to rotate around 2 different axes. I'm going to say that I want to go 1 in the x, 1 in the y, and 0 in the z. And let's go ahead and also multiply by turn speed, multiply by time.delta time. We learned our lesson last time, so we're just going to go ahead and add that. And then for our speed here, we're just going to turn this into turn speed. Cool. Save that. Come back over here. Let's click on our cube. We should see that we have a speed, but also now a turn speed once this loads. There we go. Perfect. And the turn speed is going to have to be a little bigger. I'm going to make mine 30 because we're talking in degrees now and not meters, right? So each degree is really not going to be that big of a change. So I'm going to change 30 degrees here. Now when I click play, something really interesting is going to happen. You're going to see this thing rotate. Maybe I should, oh, you know what I did? I commented out, I forgot I commented out the transform. Well, I guess let's first take a look over here then. With just the turn speed going, we can now see that I'm rotating in both the X and the Y direction at a speed of 30 degrees per second. And there it is, it works. You can use this for power-ups and different like kind of visual elements in your scene. You can even attach this to a directional light to get a cool night and day cycle. So there's a lot of cool things that we can do by rotating with code. Now whenever I translate back, here's where we're going to see something really bizarre. We hit the play button and it's going to do the translate and the turn at once. And what that does is creates this really strange kind of floaty animation where this thing is just kind of bouncing around our scene. Now if I have my global location on, check out where my cursor is. See where it says global? I can switch to, I'm sorry, it says local, but I can switch to global. If I have global on, then the Y is always pointing up. But if I switch it to local, I can see that this cube is only moving up, but it's moving up in relation to whatever direction it's turned, right? Which is kind of problematic because I just wanted this to rise up constantly while it turned. So what I'm going to do here is I'm going to add that second argument that I mentioned to the translate function. So translate actually takes 2 different properties. You can give it this value, which is the vector 3 value, that's the X, Y, and Z position that it expects to move every frame. But it can also, if we use a comma, it can also take a second argument called space.world. And what that does is it tells it, no, I'm interested in the global up direction, not necessarily the up of the cube itself. So if we run our program now, it lifts straight up. Cool, while rotating. So it's rotating, rotating, rotating. You can see that the Y, the local Y direction is spinning all over the place. But if we change this to global, we can see that it's lifting straight up, straight up, straight up, all the while spinning too. So cool, this has been a great exercise. We can now see that we can move our objects not only around the scene view using the widgets, but also during the play mode using code too, which can be a really powerful element to add into our games.